Hey guys, and welcome back to the channel. Today we're gonna do Advent of Code 2023 Day 3. As I've seen on Reddit, some people had trouble parsing the input or actually understanding what needs to be done. So I thought we'll look into the problem a bit more in detail and only show the code quickly. As usually, I've got my GitHub repository linked down below. So if you're interested in the code, you can check out my repository. So today we had a grid, and that grid contained numbers and symbols, and we had to find out whether those numbers were adjacent to a symbol or not. So as usually, it's really important to read the instruction properly. So some important things to know today were any number adjacent to a symbol. So it's also diagonal. And periods do not count as a symbol. So those things are really important to understand. So if we look at the plus symbol here, the adjacent items will actually be the cube around here. And if we think about it as a 2D coordinate, for example, let's say that's x5 and y5. How do we get those adjacent numbers? If we take our plus and check what is the coordinate of that point. Well, it's actually just subtracting 1 from x. So it's 4, and depending on how you look at the grid, either adding 1 to y or subtracting 1 to y. Let's do it mathematically. So up is adding to it. So we say our grid is like this. So the top left corner is 4 and 6. Now let's check for the top right corner. The top right corner is x plus 1, so 6. Also y plus 1, so 6, 6. Bottom left corner is also x minus 1, so 4, and y minus 1, so 4 as well. Bottom right corner is x plus 1, so 6, and y minus 1, so 4. Those are all of our corners. So we also need to have straight lines. So the one on top is just adding 1 to y, so it's 5, 6. The one on the right is adding 1 to x, and y stays the same, so it's 6, 5. Down is y minus 1, so 4. X stays the same, 5. And now the only one missing is to the left. To the left is x minus 1, so it's 4, and y stays the same. So for our point, 5, 5, those are the ones adjacent in a straight line. And those are the ones that are diagonally. Now, if we look at how they are constructed, we see that we always have 3 coordinates that have the same y value. Those have 6, those have 5, those have 4. And then it always repeats 4, 5, 6, 4, 5, 6, 4, 5, 6. So if we look at that code, we have a nested loop. We say delta y is in the range of -1 to 1. And delta x is in the range of -1 to 1 as well. And then calculate our current x based on x plus dx and y plus dy. We get all of those values. Let's quickly do some examples. We have dy minus 1, dx minus 1. Take our value 5, 5. So cx in that case will be 5 plus minus 1. cy is 5 plus minus 1 as well. So cy and cx are both 4. And that's our first case in here. Now in the second iteration, cy is still 5 plus minus 1, and cx is 5 plus 0, which will give us 5 and 4, so we have that in here. Continuing, only that value will change. We have 5 plus 1, which will lead to 6, and we have that case here. Now we've looped through each value where dy was -1, and the outer loop will continue. dy will be 0. dx will start at -1 again. So we have 5 plus -1, that's 4. And we have 5 plus 0, which is 5. So now we're at that coordinate. And if we continue with the loops, next we will have 5, 5, then it will be 6, 5. And then it'll switch over to y being 6, so we will start here, then go here, then go here. So it's really important to understand that loop structure and know how to get all the coordinates that you actually need. So now we know how to calculate the adjacent coordinates. Let's look at the problem description again and see what we actually need to do. So any number adjacent to a symbol, even diagonally, is a part number and should be included in our sum. So if we look at the example grid, we can see 467 is valid because of the asterisk, 35 is valid, 633. Here, 617 also, 592 has it diagonally, same with 755. There is a symbol and there's a symbol as well. So the only numbers that don't have a symbol adjacent is that one and that one. So those won't be part of our sum. And again, it's important to know periods do not count as a symbol. One other important thing is we're not looking at digits here. So this number is 633 and not 633, which makes parsing of the input a bit harder because you can't just iterate through every value and then check for each digit, but you actually have to check for numbers. And now if we quickly look at the code, I did it with a regex. I captured one or more digit, transformed it to an integer, and checked every match of that regex. So I had every number that was in there. So now let's look at the isPart function. I first look before our number, after our number, up and down. So if the index where a number actually starts, and I check if the number before that index is valid or not. If it's valid, I can directly return. Same happens with the end index. What's important to get right here is we take the index before our start index, but we take the end index directly because the upper bound of the range is not contained in the range. So the upper bound of the range is not the last digit of the number, but the character after the last digit. So it's important to have those two right, else you will be off by one. And now for up and down, there's a bit of index magic in there. So if you have a grid with values like we have here, you can either have them as x and y coordinates, but if it's actually not an indefinite grid, but just a square or something like that, you can also store it in a one-dimensional array. You would start at the first row, get all those values into the array, then you go to the second row, take all those values in the second row, and put them in the array as well, but after the first row, and you just continue adding those rows. And if you now know the row length, you know that the indices of the first line are actually 0 to 9, and the second line are 10 through 19, and the last line then would be 90 through 99. And that way you don't need to use a two-dimensional array, and you can just use it in a one-dimensional array, which can sometimes be a lot easier to work with. One other important thing to notice, in a mathematical way, there will be 0, 0 down here, and then everything increases to the right and increases to the top. What you usually do in programming is you have 0, 0 at the top, so y gets bigger when you go down and x is bigger when you go to the right. That's how I did it as well. If you have a string or something like that, it's actually easier to look at it that way. It doesn't make a difference in that example because we don't need to know whether the symbol is on top or at the bottom of it. So we calculate a start index and an end index. Now let's quickly think about an example. Let's say that is our grid and we're currently at that position. Now what we do is we take our start index, which is 0, 1, 2, 3, 4. Take the row length, which in that case is 3. 4 minus 3 is 1. And then subtract 1 from it, so we're actually at 0. That's because it can also be diagonal. So that's our start index. Our end index is the end index we have here, which is 5. 5 minus 3 is 2. So what we're currently looking at is actually that row. And if we check downwards, it's start index plus row length minus 1. So we have 6, 7, 8. So 4 is our start index, row length is 3, so it would be 7. Minus 1 is 6, so we take that one. And we go to our end index plus row length, which is 5 plus 3 is 8, so we have that one. Now we would iterate through that row. Now the only thing that's left is going from start to end, and we check for every character in that substring, is it valid or not? So that's the solution for the first part. So for the second part, what we need to do is find asterisks. So all the asterisks in that case would be here, here, and here. And then check whether there are two numbers adjacent to them. So the first one is adjacent to 467 and 35. The second one only has one number and the third one has two numbers as well. So what we would do now is we would multiply 467 times 35 and 755 times 598 and then add these numbers up. I used the same ideas as in part 1, but I did it a bit differently. So I searched for every asterisk and then I just hard-coded minus row length minus 1, minus row length plus 1, and all of these numbers are basically just what we did in the beginning, but instead of having y in there, we just have minus row length, which is basically y minus 1. We have plus the row length, which is basically y plus 1. So that's just going through every adjacent coordinate that each asterisk has. And then we check if that adjacent coordinate that we're looking at is actually a number. So let's quickly look at what we're actually doing here. Let's say we have a row and we're currently looking at the 3. We start with an empty array, which is result, and current starts being the index we're currently at. We will first fill up to the left. So we will start to add 3 in here. Then the index will change to 4, to the index of 4. Add 4 in there. Then it will change to the 5. add 5 in there, then we will see, okay, that's not a number anymore. And then we change to fill to the right. So we go back to the 3, directly go to the 7. That's the index to check plus 1. We add 7 to it, we add 1 to it, and then we will see that we don't have a number again. And that way we found the number 54371. So that's a neat little trick to make sure that we get the whole number and not just match 371 or something like that. So important to note, we got 3, then we first went left and after it we went right. One other important step is that we keep track of the numbers we've already seen. Going back to our example where we had 54371, and let's just imagine that the asterisk we are looking for is here. So what would happen is we would first look at the 4, go left, fill up the number, go right, add that to our result. In the next phase, what we would actually do is check if there's a number on top. We would get the 3, go left again, go right again, would add that to our result as well, which would lead to having more numbers in there that we actually need. So it's really important to keep track of which numbers we already added. And it's also important to note the whole grid can have the same number twice. So it's not enough to just use a set or dictionary to make sure that we have only unique values in there, because that way we could also lose some numbers. So that's what I check here. Have I already looked at the number starting at the index? Loop through each asterisk. Once I've seen every adjacent of a asterisk, I check whether the asterisk has 2 adjacent numbers. If so, we will add them to our result. That's part 2 done. Thanks for watching. I hope you learned something or at least had some fun. If you want to check out the code, head over to my GitHub repository and see you tomorrow.